All right, good morning, everyone. Thank you again for joining us today for our webinar, Hidden Exposures in Higher Education. Presenting today, who you can see on your screen there, will be two of Forensic Analytical Senior Project Managers, Lydia Feng and Madeleine Dangazyan. Lydia has been a project manager at VOCs for 10 years, managing and providing assistance in numerous environmental health and industrial hygiene projects, including chemical exposure assessments, indoor air quality investigations, Legionella and water quality assessments, and mold and moisture assessments. Her projects have taken place in various settings, including schools and higher education, hospitals, laboratories, construction sites, industrial facilities, residences, and more. Madeleine has been a project manager at VOCs for 7 years, and she specializes in industrial hygiene project management, including occupational and environmental exposure assessments, indoor environmental quality services, and wildfire and structure fire assessments. She provides in-depth assessments involving a variety of hazards, including indoor air quality, preparation of reports with conclusions and recommendations for compliance with wide health and safety regulations and industry standards. And before I hand it off to Lydia and Madeleine, I'm going to quickly cover just a few components of the webinar platform we're using today, GoToWebinar. Everybody is in listen-only mode except for myself and the presenters, but this does not mean that you can't communicate with us. You'll see a question panel or a chat panel on the right of your screen. So please go ahead, and as you think of questions throughout the presentation or have anything you need to communicate with us about, you can enter that in the chat or the question section. In the last 10 or 15 minutes of the presentation, we'll have a Q&A portion to answer all of those. So with that, I will hand it off to Madeleine and she'll get started.
Thank you, Taylor. Thank you for that wonderful introduction. And thank you everyone who is taking time to join our webinar today on hidden exposures in higher education, colleges and university settings. So let's just go ahead and get started. And so colleges and universities offer a wide variety of majors programs and courses, stemming from automobile shops to pre-med degrees that involve working with a wide variety of materials and agents and chemicals, from engine oil to preserved specimens. In this presentation, we will be talking about some not so obvious sources of exposure to obvious and not so obvious agents. So we will be presenting to you case studies in the following areas that both Lydia and I, in fact, have conducted exposure assessments on college or university campuses. So we're going to review some assessments that we've done in laboratory settings, in office buildings, as well as craft shops, wood shops, automotive shops, welding, groundskeeping, as well as other miscellaneous areas that we thought would be very interesting as well. So I'm going to start off with laboratories. And so, upper education or higher education colleges offer a wide variety of laboratory courses or courses that involve laboratory work, right? We have biology, we have chemistry, we have physiology and anatomy. K through 12 schools, specifically high schools, offer laboratory courses or classes as well. However, typically in these settings, they deal with low-level hazards, fairly benign. Whereas upper education, such as chemistry, biology labs, we're working with a lot more chemicals, performing experiments, synthesis experiments in organic chemistry, and so forth. Most times, the agents that students and staff and faculty are working with are known. Experiments are well designed, and prior knowledge is provided as far as what reagents are going to be utilized during that particular experiment. However, we also have in upper education research laboratories that deal with higher hazards or more hazardous chemicals. They deal with performing experiments or synthesizing using more hazardous agents than general laboratory classes would. So I just as an example, there was an incident approximately 10 years ago where we had a research student in UCLA who was working with an agent that spontaneously ignites when it comes into contact with air. And unfortunately it did. It caused a fire. Her clothes caught on fire, and she unfortunately succumbed to her injuries and passed away. And it was reported that she had only been working with this hazardous chemical or this hazardous substance just this twice while performing research for faculty at the university. So hazard communication, is key. Knowing what chemicals and reagents are going to be worked with is key. A lot of work in biology and chemistry labs are performed under local exhaust ventilation. So that's great. But knowing beforehand the hazards, reviewing safety data sheets, reviewing that with staff, or staff reviewing that faculty and students, reviewing those prior to working with them is key. Then we go to analytical laboratories, which, not analytical, I'm sorry, the anatomy laboratories or physiology laboratories. They deal with specimens, and these specimens are preserved in solution, in fixatives. So what chemicals do they normally, or do they usually contain, right? Some of the obvious ones are formaldehyde, but some of the non-obvious ones are like glutaraldehyde, which is another form of aldehyde, which is not very friendly. It's not a very nice chemical to be around or to be exposed to. They could contain phenol. They could also contain methanol, and maybe others. We don't know. So I just wanted to highlight formaldehyde. And that's one of the chemicals, that's one of the agents found in preservation solutions that specimens are fixed in. The reason I wanted to highlight this is formaldehyde is one of the chemicals that has its own standalone OSHA standard, okay, as well as a Cal OSHA standard. So besides the permissible exposure limit, this standard also lists other limits that require specific actions to be taken if these limits are met or exceeded, such as requiring annual training for all those workers, employees, staff who exceed a 0.1 ppm limit. It is a colorless gas. It has a very pungent odor. Its odor threshold is the lowest concentration that anyone can smell. This is at 0.05 parts per million. That's only 50 parts per billion, so it's significantly low. It's volatile, it's flammable, and as I mentioned before, it is used in embalming and tissue preservation. It's also classified as a human carcinogen by OSHA. It is a confirmed human carcinogen by ACGIH, formerly known as the American Conference of Governmental Industrial Hygienists. The most common cancer it causes is the nasopharyngeal, or the nasal cancer. It targets the eyes, skin, respiratory system as its target organs. Long-term exposures to low levels of the agent can cause respiratory difficulty, eczema, and sensitization. And sensitization essentially means that there are changes that occur in the organism, usually the immunological system. So by exposure to a chemical, and at further chemical exposure, even at lower levels, can lead to recognition and the reaction by the immune system for that particular chemical. So next I want to present several case studies that we've performed on upper education campuses, college and/or universities. This first one I want to talk about is an anatomy / physiology lab. We were contacted in order to do a baseline survey of a human cadaver course that utilizes human cadavers during their instruction as one part of their anatomy course. The baseline included doing a survey or an exposure assessment during a standard instructional course. And the picture depicted on the bottom there, that's during a regular laboratory class, as well as a prosection or dissection. And what that means is colleges will receive human cadavers, usually on a rotating basis. Every 5 to 7 years, older cadavers are sent back and new cadavers are received. And when these new cadavers are received, instructors or faculty will have to prepare them for subsequent courses. So they have to go through and do dissection. And in the upper right corner of the slide is when they're actually working on a newly received cadaver and they're doing the prosection. So, exposures to formaldehyde and other agents, other potentially harmful agents, are often overlooked because, as you can see here in these photos, we're not seeing any local exhaust ventilation being utilized in order to remove vapors away from the faculty that are working on the specimen. Additionally, when we have new cadavers, and I'll go into that too, we're going to be getting, off-gassing a lot more of the agents because it's freshly embalmed. So you have a lot more off-gassing occurring on newer specimens. So what did we do for this survey? We conducted exposure monitoring, so testing, as I mentioned, both in the instructional laboratory as well as in the prosection room. The instructional laboratory setting was typical lab setting, comprised of laboratory benches, workstations, but no local exhaust ventilation was used. The cadavers, I believe there were 3 total that were wheeled into the classroom. They were unzipped, and a couple of the cadavers were used as instruction for students by the faculty, and then 1 cadaver was actually being marked where students would subsequently perform a quiz and identify whether muscle groups or organ groups and so forth. Both personal breathing zone samples and area samples were collected during the survey, both long-term, meaning the span of the entire lab session, as well as short-term, meaning 15-minute samples were collected. Now, in this particular survey, the students were only working with cadavers. However, I just wanted to also pinpoint there are other specimens that students work on during anatomy and physiology labs, such as cat specimens, other organs, such as sheep brain, heart, and so forth. So what were some of the results? Well, formaldehyde, the 8-hour time-weighted average actually exceeded the Cal-OSHA action level of 0.5 parts per million and the permissible exposure limit of 0.75 parts per million. Additionally, the 15-minute short-term exposure sample that we collected the results were at 2 parts per million, which is at the limit. In addition to formaldehyde, we also sampled for phenol and glutaraldehyde. Well, both agents had measurable levels in the samples that were connected. So therefore, in addition to formaldehyde, we have these 2 other agents that were present, and they were measurable, although they were below occupational exposure limits. Now, just a little bit more info on phenol and glutaraldehyde. Although they don't have their own standalone standard by OSHA, they are hazardous materials. For example, phenol has a permissible exposure limit of only 5 parts per million, so it's significantly low. It could cause upper respiratory tract irritation, lung damage, as well as the central nervous system. Okay. It is a hazardous substance that can cause severe health hazards. So this is something that generally, most oftentimes, may not be looked into when we're assessing exposures during specimen, doing these types of laboratories, because the go-to is always formaldehyde, because that's one of the predominant agents that are in preservation solutions, right? Next is glutaraldehyde. Again, this is another aldehyde, and it's not very nice to work with. It also causes upper respiratory tract irritation. It could cause respiratory and dermal sensitization, as well as the impairment of the central nervous system. Its lowest occupational exposure limit is listed as 0.05, only 50 parts per billion, as a ceiling limit. And what that means is this is the maximum exposure limit which cannot be exceeded for any length of time. So forget about in 8 hours. At any length of time, we cannot exceed 0.05 parts per million or 50 parts per billion as an exposure, as an OEL for this aldehyde. So what are some of the controls that can be done, right? So we need to anticipate the source of exposure. This is coming from whether it's a chemical that's being utilized in a chemistry laboratory, whether it's coming from a solution that's being used to preserve tissue. We need to look at all aspects of the sources, not just the direct source, not just the obvious one. And by doing that, we need to review safety data sheets, right? And then take into consideration all other harmful agents, not just the obvious, as I mentioned before, because with these other agents, they could create an additive or synergistic effect if combined with the obvious agent of exposure. So, additive effect would be the sum of equal. The sum would be equal to the individual exposures of the agent. But synergistic, the sum would be greater than the individual effects of these agents. So all of that needs to be taken into consideration if they impact the same system in the body. If they impact the same target organs in the body, they would have additive or synergistic effects. So how do we control if we see some SGSs that actually have, proprietary ingredients listed as their primary ingredient? What do we do there? How do we control if we don't know what the actual active ingredient is due to trade secret? Well, that takes a little bit more digging into. It takes expertise, knowing that from past and previous experiences, connecting with a consultant to review this, to review the processes and provide recommendations as to what potentially can be present in this agent or in this solution where proprietary ingredients are listed as the primary. And then provide recommendations of how to maybe monitor for it and evaluate for it, and then confirm that exposures are not exceeding occupational exposure limits for certain hazardous agents that could potentially be present in the solution. Okay, so how do we? What other type of controls can we do? Well, we can eliminate the source, meaning eliminate it altogether, or potentially find a substitution for it. But we need to be very careful because we can substitute for a source. As an example, the Carolina Perfect Solution says it's formaldehyde-free preservation solution. But we've been involved in actually 2 surveys at 2 colleges where the laboratory was using formaldehyde-free Carolina Perfect Solution for their CAT specimens. But levels were found to be at 0.1 ppm, which actually triggers the annual training requirement based on the Cal OSHA formaldehyde standard. So these specimens were initially fixed in formalin, before being put in the formalin or the formaldehyde-free solution. You know, the SDS lists proprietary ingredients, but doesn't explicitly say that there is no formaldehyde. So we need to be cautious when we are evaluating these safety data sheets and ensure that truly that exposures are below the standard limits as mandated by the standards or by OSHA. Other controls that can be utilized, there's engineering controls as well as administrative, and PPE is last. In the hierarchy of controls in industrial hygiene, PPE is the last control to use, because that essentially is when all other measures have been exhausted and we still cannot reduce exposures to below occupational exposure limits. Or we use PPE until all the mitigation is implemented and confirmed that exposures are below occupational exposure limits before removing staff from these PPEs, such as respirators. There are other engineering controls. I mean, there's new technology, as you can see in this bottom photo, which is actually kind of cool. It's a virtual dissection. So you're looking at a cadaver, but not necessarily a real cadaver. It's a virtual, and students are able to go through and learn all the different organs of the body, muscle groups, bones, etc. Everything that they need to do in an anatomy laboratory, but minus the actual physical cadaver. We also have other local exhaust ventilation that can be utilized, like a snorkel flex exhaust in the bottom right corner of the slide. There are also downdraft cadaver workstations in the upper right corner. So that actually has slots where it pulls vapors away from the worker's breathing zone as they are working on cadaver specimen samples. Other factors that should be considered when installing controls, new cadaver versus older cadavers. New cadavers come in and they have fresh embalming solutions. So they're going to be off-gassing hazardous agents or reagents far more than older cadavers, which have already most likely off-gassed this. We need to consider surface area, the flesh size of the cadavers. Larger surface areas will emit more off-gassing and more vapors into the atmosphere. Again, costs with new technology versus local exhaust ventilation, that could be a deciding factor as to what kind of a control should be implemented. Something else to think about if specimens are not stored in specific coolers or areas that have local exhaust ventilation, new specimens that come in, consider storing them right in front of a fume hood and allowing them to off-gas for several hours, several days, and that will help with the initial off-gassings, especially with newly arrived specimen samples. Okay, so next I want to talk about some hidden exposures potentially in office buildings. Now, generally we don't, consider hidden exposures here because people don't typically think about it, since it's an office building, or it's an office, right? So we were called to assess an office building on a campus. This particular building had gone through new renovations. It was completely renovated, actually. So new flooring, new furnishing, newly painted walls, as well as a new decorative wall was installed. Shortly after, this was done over a summer. And shortly after, staff started, when school semester resumed, they started exhibiting some symptoms, mainly itchy, watery eyes, upper respiratory tract irritation, a scratchy throat, headache, and at least one occupant reported a rash. And so we were contacted, and through discussions with representatives, we did some research as to all of the materials that were installed, new flooring, carpeting, what adhesives that were used, looked at safety data sheets, that what could potentially be the source of the symptoms that was reported. And through conversations, we decided that we were going to be, monitoring for volatile organic compounds as well as formaldehyde. And I'll get into really why we decided to assess for formaldehyde in a couple of slides. So we did some area monitoring. In the bottom left corner photo shows area samples being collected near that decorative wall, as well as in an area where new carpeting was installed, as depicted in the photo in the bottom right. And then we also did some whole air sampling for VOCs over a integrated time, about 4 hours, I believe, and using an evacuated Suma canister. Following sampling, the results indicated that there were measurable levels of formaldehyde in all indoor samples. Highest levels were measured at the or near the decorative wall, so about 31 and 34 parts per billion. The levels observed were, higher than the recommended public health agency levels for sensitive individuals or the sensitive population. And additionally, the formaldehyde can exhibit symptoms as low as 10 parts per billion concentrations. So eye irritation can occur at about 10 ppb, nose and throat at about 100 ppb. And we were seeing anywhere from 31 to 34 ppb. So that could certainly account for the itchy, watery eyes that occupants had reported. It's also a sensitizer. One employee reported a rash. Well, what can happen here is an allergic reaction can occur to formaldehyde, a dermal reaction, not just through dermal contact, but by inhalation too. And as I mentioned before, sensitization is, when your immune system reacts and it's been exposed to an agent or a chemical for some duration, and then later on, at lower concentrations, when someone or an individual is exposed, then the immune system will react. And in this particular one, it could react as a dermal reaction, or it manifests into a rash without even having to touch that chemical, just through breathing in the vapors. So the volatile organic compound analysis that was done, results came back as negligible. All compounds that were identified were typical for an indoor office setting or an office environment. Nothing elevated, especially with all the new materials that were installed during the renovation, such as flooring and cabinetry and other furniture. So what could potentially have been the source for this formaldehyde that we detected in the sample? Well, formaldehyde is used as an adhesive. So in the form of urea formaldehyde resin, it is used in glues and adhesives and sealants that go into the manufacturing of composite wood products, such as particle board, medium density fiberboard, and so forth. So the decorative wall could have contained this adhesive, right? Generally, it does not, it won't be an issue because the formaldehyde is bound to this large urea compound. The only time it becomes an issue when is the wood is actually manipulated. So when it's cut, when it's drilled, when it's hammered, you might break that bond, and that free formaldehyde molecule now is in vapor form, it's airborne, and that can be inhaled. So what kind of controls can be done? To do the homework and get a good understanding of what materials are being utilized or installed during any type of renovation. Increase the ventilation in order to help off gas. Eventually it's going to off gas and it'll stop. An increase in the mechanical ventilation, meaning running the HVAC system 24/7 in order to help with the dilution, isolating the area, and then airing out the source. And the way that we isolate it is you put in a poly sheeting, and a negative air exhaust was installed in order to exhaust everything outdoors in order to help ventilate it. And next, I'm going to review some exposures from wood shop or craft shops that are offered as programs for upper education colleges and universities. So, wood shop is one of the several trade shops that is offered in higher education, and students are taught woodworking methods such as sawing, sanding, cutting, and painting. And a quick overview of what we did on this one particular campus. We were hired to do an assessment of total wood dust during woodworking activities for one of these courses that's offered on this college. So the area was like one large room of approximately 25 pieces of equipment, such as, cutting, sanding, drilling, sawing equipment. Woodworking stations were equipped with local exhausts, and those were attached and connected to dust collectors, such as the photo that's depicted in the upper right on this slide. Except for table saws, the photo on the bottom, you can see a table saw, but there is no local exhaust ventilation in order to draw airborne wood dust during sawing activities. So what are some of sources of exposure? Well, the obvious one is the wood dust, right? That's the obvious one. All soft and hard wood will create airborne particulates. But the not so obvious one could be Western red cedar. If Western red cedar is worked with, now we have to deal with a lower occupational exposure level. So in comparison, the permissible exposure limit for wood dust by OSHA is 2 milligrams per cubic meter for an 8-hour time-weighted average. Whereas the Western red cedar, it's only 0.5 milligrams per cubic meter. So just as a reference there. Of course, there are obvious exposures from varnishes and paints that could emit volatile organic compounds. Even though some of them they might say low VOCs, they still have VOCs, and that's a potential exposure. But as discussed previously, what about formaldehyde? We don't necessarily think about that exposure. If we're working with manufactured or MDF or press board particle wood, and they're manipulating that, then there might be a potential exposure to formaldehyde. Just as a quick example, there was a college that I was asked to come in and do an assessment for an office space. Now, this office space was located next to a wood shop. And one time, one day, the employees in the office space, they started, detecting odors. They started feeling bad. They had itchy, watery eyes, as well as, one employee felt so bad that they had to leave early to go home, leave early from work. Well, come to find out that the wood shop, students were working on their projects, and they were doing a multitude of different projects, from welding to spray painting to working with wood. And they were doing this all outdoors, and this was adjacent to this office building. Well, what happened is we, in doing an investigation and speaking with the wood shop faculty member and instructor, we come to find out that they had brought in an alternative wood, basically an MDF, because they thought that that was a better material to work with during this project that they had to complete. And that released the formaldehyde, which got into the mechanical air handling system for the adjacent office building and introduced formaldehyde there. We were called in to do an assessment, take some samples just to ensure that there weren't any residual levels left before workers came back and reoccupied the space. So that's another hidden source, because internally there was no sources producing these agents that caused employees to exhibit adverse health symptoms in the office building, yet the source was actually next door at a wood shop. So again, another example of a hidden source that they didn't really think about, right? So back to the wood shop that we did test, we performed both personal and area monitoring for total wood. It was during a regular class session. Both short-term and long-term samples were collected. And the results indicated that the long-term were below the occupation exposure limits for an 8-hour time-weighted average. However, they did exceed about 50%. They were at or exceeded the 50% of the OEL, which is always like a little triggering point for us to say, hey, we need to look more deeply into the controls. However, the 15-minute short-term sample did exceed the STEL limit for wood dust. And so what can we do in order to control these? Well, dust control systems, right? Dust collection systems, excuse me. They have these installed, but what we need to do is ensure that they're being evaluated routinely, making sure that they're working properly, making sure that they're drying properly, making sure that there aren't any tears or breaks in the ducting system that could potentially leak and not the system is not performing up to its capacity or its efficiency. Using wet wipe techniques, using wet wipe cleaning techniques instead of dry sweeping techniques in order to clean up. Like I said, with the use of LEV for all equipment that potentially can create airborne dust particulates. Not using a compressed air to clean surfaces. And the photo in the middle, you can see the instructor that was being monitored. They're cleaning the filter that is used in the dust collection LEV, cleaning it by using compressed dry air. Well, that's making you can see the dust clouds that it's emitting, and all of that is being is going into the breathing zone of the particular individual. The upper right corner photo depicts dry sweeping, and again, you could see dust being emitted or airborne dust being created, and that's at an outdoor location. And then the bottom left corner photo is dry sweeping in the classroom, an indoor location. So all of these are of controls that should not be utilized. They should be using better controls as far as doing the cleanup, meaning the wet methods, or using HEPA vacuuming and having the dust go into an actual collection vessel. And so with that, I will now pass it on to Lydia Feng, who will be talking about exposures in other programs that are offered in colleges. And I will pass it on to Lydia.
Awesome. Thanks, Madeleine. Okay. I'm probably going to try to talk a little faster to make sure that we end on time, but we'll make sure to cover everything. So next, I'm going to talk about exposures. You can go to the next slide. In another common program that's offered in higher education, which is welding. So many types of hazards in a welding shop, including lots of different safety hazards like UV radiation, noise, burns, eye damage, just to name a few. But today we're just going to talk about one hazard, which is welding fumes. So welding can get quite complex because there's lots of different types of welding. So I'll just start to give you a little bit of background. So electric arc welding, or just arc welding, is probably the most widely used type of welding. And this the welding process produces harmful metal fumes and gas byproducts. So depending on the type of arc welding, the amount of fumes produced varies. So you can see in the graphic. So the types of welding are kind of arranged by the amount of fumes produced. So there at the top, you have flux core arc welding, which produces the most welding fumes, followed by shielded metal arc welding, gas metal arc or MIG welding, and then tungsten inert gas or TIG welding. Okay, and then there's many factors that affect someone's exposure to welding fumes. So the type of welding, the type of materials used, the location, whether you're outside or in an enclosed space, how the work is being performed by the welder, as well as like ventilation and air movement conditions. The next slide. Okay, so what exactly is in welding fumes? So depending on what type of welding and what materials are used, welding fumes can contain various different harmful metals and gases. So for example, with metals, you could have arsenic, beryllium, chromium, lead, manganese. For example, gases produced can include carbon monoxide or ozone. Immediate health effects from exposure can include things like eye, nose, throat irritation. And then with prolonged exposure over time, there can be increased risk of health effects like lung damage, cancers, metal fume fever, even Parkinson's-like symptoms. So, and then one particular chemical to point out is chrome-6. So chrome-6 is highly toxic, and it's produced when welding with materials containing chromium. So examples of this include stainless steel or chromate coatings. So that is something to definitely be aware of. Next slide. So as far as controls, so controls are critical to reducing exposures to welding fumes. So obviously, if you can, use less toxic materials or consumables, use the lower fume generating welding types. General ventilation is very important. A lot of welding shops tend to have excellent general ventilation. Local exhaust ventilation is also really important. These can include fume hoods, fume extractors with like flexible snorkels that are designed to be moved. And then, with local exhaust positioning is very important. The position of the LEV relative to the worker, relative to the source. And then making sure to keep the welding surfaces clean is something to consider as well. Next slide. Okay, so I'm going to talk just a little bit about an exposure assessment that we conducted at a welding program at a community college and some of the things that we learned from that survey. So this college actually requested an assessment because the instructor was concerned about exposures and there being possibly like inadequate engineering controls. So there's some photos from the shop. The shop had like, give or take, like 20 welding booths for different types of welding. And from sort of initial appearances, actually did have a lot of controls in place. So for example, they had local exhaust ventilation at all of their welding booths, either fume hoods or these like snorkel fume extractors, like you can see in the photo. Good general ventilation, a big open shop with exhaust fans. Also, as a policy, the program also did not use any stainless steel or other chromium containing materials. So initially, first appearances, things looked, like things would be okay, like pretty good controls in place. Next slide. So for the assessment, we conducted exposure monitoring of their more hazardous welding operations in the program. And then what the results found was fairly high levels of manganese. So when you look at the photo, this is a photo from the survey, it's not hard to see why. So there were definitely some issues with the positioning of the local exhaust systems. So although the snorkels were designed to be movable and you can move them, the particular snorkel, here in the booth was placed above the person's head. So the fumes basically have to enter the welder's breathing zone before being drawn into the snorkel. And also the distance was too far. So you can see that the opening of the snorkel was almost like 3 feet away from the source of the fumes, it was just too far to adequately capture the fumes. right? So the lesson there is just because engineering controls are in place, that itself, it's not enough. You can't be complacent. It's important to train the students in the proper use of the LEV systems. And then, if the controls are not used properly, they're not going to be effective. So maintenance issues were another thing that we discovered. The snorkels were there, but they had issues like torn ducting, like detached parts. Sometimes the dampers weren't even open. So again, this highlights the point that you can't assume because the engineering controls are in place that they're going to be effective. So training, maintenance are really crucial to making sure that you reduce exposures. Next slide. All right, so we're going to move on to potential exposures in another area, which is auto shop. So auto repair maintenance, another commonly offered program in higher education. So again, in this area, numerous hazards in this line of work. So for one, many chemicals present in this industry. So auto shops are working with a wide variety of chemicals that have risk of serious side effects if people are not using them properly or not properly protecting themselves. There's ergonomic hazards, safety issues with the machinery and the tools, flammable substances, trip hazards, flying debris, and noise, just to name a few. Next slide. Okay, so looking just at the hazards from chemical exposures, there's quite a lot of things to consider. You can have exposure from engine exhaust, which can put people at risk of carbon monoxide poisoning, asthma, exposure to solvents from the cleaners, which are linked to nervous system or reproductive system damage, cancer. There's dust from sanding, welding fumes, like we talked about. Some of the more sort of hidden exposures that people may not be aware of include asbestos. So there's actually potential for exposure to asbestos because some brakes and clutches that are in use today, especially with the older cars, may contain asbestos. Okay, so when people repair or replace brakes and clutches, they could be exposed to asbestos dust. As a best practice, OSHA actually states that mechanics should assume that all brakes have asbestos, since you can't tell just by looking at them. And then another sort of hidden hazard, a hazard that people don't commonly think about, is dermal exposure. So with dermal exposure to a lot of the products, people can have skin reactions, skin rashes, or dermatitis over time. Next slide. Okay, so as far as controls, some of the controls that can be taken to help reduce exposures to hazardous chemicals include trying to switch to water-based cleaners if possible, rather than petroleum-based products, ensuring adequate ventilation. If the cars are running, using those exhaust hoses to exhaust the fumes outdoors, keeping any dust wet if you can, never clean with compressed air, especially when repairing brakes and clutches. And then again, being mindful of dermal exposure. People should wear gloves, and nitrile gloves, not latex. There are lots of options. They're really thin, low cost, no nitrile gloves that are available. All right, next slide. Okay, and then to share some of the experiences we've had, we had a college contact us requesting an assessment at their automotive technology program, and they specifically requested an air quality assessment, mainly because they were concerned about inhalation exposure. Let me see. Okay, so for our assessment, we looked at their SDS sheets. We conducted monitoring for some of the VOCs, and when we got the results, it turned out the results were fairly low, well below OELs. But the issue that we did see, which was not what they initially contacted us about, was the lack of consideration for dermal exposure. So as you can see from the photos at the bottom, the instructors using a solvent to clean parts at the sink and not using gloves. And then, talk about setting a bad example for the students, right? And then in the photo above, you got a student spraying brake cleaner to the vehicle above him, also without wearing gloves. So, I talked about dermal exposure. So don't forget that dermal exposure to solvents and oils and greases can have a lot of bad effects for the skin, like dermatitis and rashes. And then in addition to that, a lot of times these petroleum-based cleaning products, like the one that was used here, they can contain things like benzene, which is a carcinogen. And so now you've got exposure via inhalation, and then you've got exposure through the skin as well. So even though the STS may not explicitly list it. All right, next slide. Okay, so while we're on the topic of auto shop hazards, I want to just spend a moment to talk about isocyanates, because isocyanates are commonly used in the auto repair industry. So not all auto shops, but mainly the ones that are doing painting. So isocyanates, highly reactive group of chemicals that are considered VOCs, but technically semi-VOCs. They're used in polyurethane products, and some of the examples of when exposure occurs is like when someone's applying products containing isocyanates, so maybe paints or foams or varnishes. Also, exposure can occur during heating of polyurethane plastics or foams. As far as health effects, isocyanates are known sensitizers, which means that if the body is repeatedly exposed to something, then the body eventually develops an allergic reaction to it. So where each time someone's exposed to that thing, the body has a more and more severe reaction to the exposure. So they're very, very nasty things. They're known to be both dermal sensitizers and respiratory sensitizers. Okay. Let's see. So another thing to know is that isocyanates are actually like a leading cause of occupational asthma. So particularly among workers in industries where they're used a lot, like in auto repair or construction. But as far as where you might find isocyanates in an educational setting, obviously trade programs like auto shop where painting might occur, but also less obvious places like research labs, theater production, art classes are certain places where you might find them used. And then this is an interesting, assessment that we were involved in a few years ago. So our college actually contacted us after they had a bunch of their architecture students in the architecture program reporting rashes. So, a bunch of the students reported rashes over a short period of time. And at first, we considered different possibilities. We considered fiberglass exposure, and we ruled that out. Eventually, what we determined was that the most likely explanation was one of the products that they were using, which was like a urethane casting resin, and the students basically weren't aware of the hazards associated with using isocyanates and not being careful as far as like PPE use, making sure to use gloves, and then probably a lot of cross-contamination occurred where they were using contaminated gloves or hands to touch personal items like phones and pens and books, and it was not good. But eventually they cleaned it up and they learned their lesson. But it's definitely something that is worth being aware about. Okay, so next slide. All right, so probably you can go to the next slide. So we'll probably go a little bit faster, but because I know we're coming up on time. So there's still a couple of topics that we still want to cover. So on college campuses, we're often dealing with campuses with a lot of beautiful open green spaces. So we don't want to forget, we don't want to forget about the groundskeepers. So we've been talking a lot about chemical exposures, but one of the significant exposure hazards for groundskeepers is noise. It's known that groundskeepers have increased risk of noise-induced hearing loss, right? Particularly if they're operating equipment without using hearing protection. Okay, so there was a study done recently, actually on university groundskeepers specifically, that found that most of the equipment that they use is usually louder than 85 decibels, which is the action level, OSHA action level, and then oftentimes louder than 100 decibels. More than half of the groundskeepers in the study had an 8-hour time-weighted average that exceeded 85 decibels, which is, again, the OSHA action level. All right, next slide. So what do we do about control? So employers and employees, they need to be aware of the extent of their noise exposures, right, and what they can do to reduce their risk. So colleges should have a hearing conservation program, and they should be conducting noise monitoring to identify the workers who need to be enrolled in the program. So sometimes, and we've seen the schools go ahead and they just enroll all of their groundskeepers, and then, making sure to administer the program and, take care of all the things like hearing protection and training to make sure they're using it correctly, and then, audiometric testing and so forth. There's also engineering controls with the equipment. So there are less noisy models for every type of tool. There's also regular maintenance, which is kind of a low cost, but really effective way to keep noise levels low. And then, some of the administrative controls that can be considered, like, reducing the duration that any one worker performs the high noise task during their shift. And then mixing it in with like the low noise tasks, signage, and then even something like keeping a healthy distance between workers, especially if they're simultaneously using noisy equipment. All right, next slide. Okay, next slide. Okay, so then lastly, before we end, I wanted to just shine a light for a moment on the topic of lead in drinking water. And the reason that I would consider this to be sort of a hidden hazard in colleges is that contrary to belief that there is still a lot of lead in plumbings, in buildings, particularly in older buildings. But because drinking water in buildings isn't required to be tested, the problems are not identified and fixed. So currently here in California, only childcare centers are mandated to test for lead, and to a much more limited extent, like K-12 schools. Colleges, they don't have to test for lead at all. And, almost none of them do it proactively. So what are the consequences of that? So to give you an example, we had a college here in the LA area that recently conducted testing of all of their water fountains prior to reopening them post like the COVID shutdown, and they found really high lead levels. So up to something like 430 parts per billion, which is extremely high. So almost 30 times higher than the EPA's limit of 15 parts per billion, which EPA already considers that to be unhealthy. So, like, even though a lot of the discussions and concerns revolve around children's exposure because they're most susceptible to the health effects of lead, something to consider that, even in a college setting, you may not have children present per se, but keep in mind you do have a lot of young adults, young women, and when women are exposed to lead in drinking water, and this is really interesting, something that I learned, the lead actually remains and accumulates in the body. And then in the future, even the far future, if the woman becomes pregnant or is nursing, the lead in her body can be passed on to the baby and can harm the development of her child. So that, in addition to myriad other health effects that could affect adult men and women. So I'll end with that, but that's something that I would strongly consider is just having your drinking water evaluated. There we go. Thanks, Taylor.
Awesome. Well, we're just up to time, but we've got time for one question here that came in. What public health agencies' thresholds did you use for the formaldehyde office IEQ investigation that you mentioned, Madeleine?
I believe that was the OEHA, the Office of Environmental Health Hazard Assessment.
Alrighty. And it's just now noon, so I want to respect everybody's time here, but we will send a copy of the, a copy of the recording of today's presentation out to everybody who attended and signed up, so you can share that with your peers, colleagues as well. We will also send out Lydia and Madeleine's contact information with that. So if you have any outstanding questions that they can answer, you can contact them directly, but that will be sent out later today or tomorrow, depending on when that video is uploaded. So thank you all for joining us. Thank you, Lydia and Madeleine, for the great presentation. And I hope everyone has a great week.
Thank you.
Have a good day.
Have a good one.